Chapter 6.1 is the angles of polygons. The segment that connect the non-consecutive vertices of a polygon are called diagonals. And we have this interior angle sums theorem. Okay. So this is the interior angles sum theorem. And what does the interior angle sum theorem state? It says that in any polygon of side number n, and it has to be convex, that the angles, the interior angles add up to this value here, which is the number of sides minus 2 times 180. Okay. So let's go ahead and try to apply it to this figure here, and we could see that n, the number of sides of the polygon, is 1, 2, 3, 4, 5. So here n is equal to 5, which means to get the angle measure of the interior angles, that would be these ones here, each one, all of them added together would equal to this value here. Okay, so to figure out what that value is, we could say the 5, substituting the number of sides in for n, minus 2 times 180. So that's going to be 3 times 180. And that's going to be 540 degrees. And so since this is a regular polygon, right, to get each angle, we could divide 540 by 5, the number of angles, right? And so what we could do is divide that by 5 if we wanted to find each angle measure, and that would equal to 108. So 108 degrees, so that means this is 108 degrees, that's 108 degrees, 108 degrees, 108 degrees, 108 degrees, right? And so that's what the interior angle sum theorem lets us say. And this is the chart form of that, using triangle, quadrilateral, pentagon, hexagon, and anagon. And you can see here for the pentagon, it's 540 degrees in total, right, of all the interior angles added together. So let's go ahead and use the interior angle sums theorem to solve problems. And the first one is we have a convex polygon that has 13 sides, right? So that would be hard to figure out with the protractor. And we're supposed to find the sum of the measure of the interior angles, not individual interior angle measure, but the sum of all of them. And how do we do that? Well, we use the interior angles sum theorem, and we're going to use this expression here to find the sum of all of the interior angle measures, right? So in this case, n is equal to 13, and we'll just go ahead and plug it in. So we get 13 minus 2 times 180. That's going to be 11 times 180, and I'll break out my trusty calculator, and I'll do 11 times 180. So it's 1980. So 1980 degrees is the sum of all the measures of the interior angles. Okay, great. So now what about this second problem? The measure of an interior angle of a regular polygon is 120 degrees. So here they're giving you one angle of the polygon. Now we're supposed to find the number of sides. So find the sum of the measures of the interior angles. Oh, I'm sorry. So this here is instructions for these problems down here. So I'm going to ignore this second line. It's a typo, right? But this is the problem. It's the measure of the interior angles. The measure of a single interior angle of a regular polygon is 120 degrees. Find the number of sides. So how can we use the interior angle sums theorem to figure out this problem here? Well, they give us the measure of one angle, right? So the measure of one angle times the number of sides, right? And we don't know the number of sides. So n is equal to a question mark. We don't know. And n is the number of sides. But if we take one angle and we multiply that by n, the number of sides, then this will give us the sum of the interior angles of the polygon, right? And so we can go ahead and set that equal to this expression here. So we're going to say is equal to n minus 2 times 180. Right? So this here is the sum of all the angles, and that's equal to the expression given to us by the interior angles sum theorem. So then we do the math, and we get 120n is equal to 180n minus 360. We'll subtract 180n from both sides. I'll get a negative 60n is equal to negative 360. We're dividing by negative 60 on both sides, and we'll get n is equal to 6. Right? And that is our final answer. So that's how you do problem type 1 and problem type number 2. And we're going to go ahead and use those strategies to solve these problems here, and I'll show you the answers in the next video.